RAM manufacturing techniques and components, a detailed overview. Basic components of a RAM module. Before diving into manufacturing techniques, let's break down the key components of a typical RAM module. First, we have the memory chips, which are the core of RAM, containing the actual storage cells. Then there's the printed circuit board, or PCB, which serves as the foundation that holds all the components. Next, we have the gold connectors, which are essential for interfacing with the motherboard. Additionally, resistors and capacitors are used for signal integrity and power regulation. And finally, the serial presence detect chip, or SPD chip, stores information about the module's specifications. Memory chip manufacturing. The heart of RAM production lies in manufacturing the memory chips themselves. This process involves several complex steps. Wafer production. Silicon ingots are grown from pure semiconductor-grade silicon. These ingots are then sliced into thin wafers, typically 300 millimeters in diameter. 2. Photolithography. The wafer is coated with a light-sensitive chemical called photoresist. A mask with the circuit pattern is placed over the wafer, then ultraviolet light is shone through the mask, hardening the exposed photoresist. 3. Etching. The unhardened photoresist is washed away. The exposed areas of the wafer are etched using chemicals or plasma. 4. Doping. Impurities, usually boron or phosphorus, are introduced to create N-type and P-type regions. This is done through ion implantation or diffusion. #5. Layering multiple layers of conducting and insulating materials are added. This creates the complex three-dimensional structure of the memory chip. #6. Testing and cutting. Each die on the wafer is tested for functionality. The wafer is then cut into individual chips. PCB manufacturing for RAM modules. The PCB serves as the backbone of the RAM Module 1. Design. The PCB layout is created using specialized software. 2. Layer creation. Multiple layers of copper-clad substrate are prepared. 3. Imaging. The circuit pattern is imaged onto each layer. 4. Etching. Unwanted copper is removed, leaving the circuit traces. 5. Lamination. The layers are pressed together with heat and pressure. 6. Drilling holes are drilled for component connections and vias. 7. Plating. Copper is electroplated into the holes. 8. Solder mask and silkscreen, applied for protection and labeling. Assembly process. Once the chips and PCB are ready, the assembly process begins. 1. Solder paste application. A precise amount of solder paste is applied to the PCB. 2. Component placement. Automated machines place the memory chips and other components. 3. Reflow soldering. The entire assembly is heated to melt the solder, securing the components. 4. Inspection. Optical and X-ray inspections ensure proper placement and soldering. 5. Testing. Electrical tests verify functionality. 6. SPD programming. The SPD chip is programmed with the module's specifications.